Hi everyone, this is my reflection for part A2 today. I'll explain how counting and probability are actually used in real world IT tasks, especially in password generation, data encryption, and risk analysis in system security.
First is password generation, counting principle plus probability. One of the most common application is creating secure password. We use the fundamental counting principle to compute how many possible passwords can be formed. Example, suppose a system requires a 6-character password using 26 uppercase letters, 26 lowercase letters, and 10 digits. Total possible characters equals 26 plus 26 plus 10 equals 62. Using the counting principle, number of possible password is 62 to the power of 6, and 62 to the power of 6 equals to 56,800,235,584. So there are over 56 billion possible passwords. Why is this important? The probability that a hacker guesses the correct password on the first try is probability equals 1 over 62 to the power of 6, approximately equal to 1.76 times 10 to the power of 11. This shows how the counting and probability help measures password strength. Next is data encryption, permutation, and key space. Modern encryption algorithms depend on the massive key spaces created using counting principles. Example, AES Advanced Encryption Standard is 128 encryption. Key length 128 bits. Each bit has two possibilities, 0 or 1. The number of possible keys is 2 to the power of 128. So 2 to the power of 128 approximately equal to 3.4 times 10 to the power of 38. This number is so huge that even supercomputers cannot try all possible keys. Why and how this matter? The larger the key space, the lower the probability of a successful brute force attack. Counting and probability directly determine how secure encryption algorithms are. Third, risk analysis in system design, probability of failure. IT teams use probability to assess risk like server downtime, hardware failure, cyber attack likelihood. Example, if a server has a 1% chance of failing in a day, the probability that it does not fail is probability of no, no failure equals 1 minus 0.01 equals 0.99. Probability it runs for 7 straight days. 0.99 to the power of 7 approximately equal to 0.93. So there's a 93% chance of uninterrupted service. This helps IT teams decide whether they need backups or redundant.
Last is real world reflection. Counting and probability may look like simple math topics, but in IT they become essential tools. They determine how secure passwords are, how strong encryption key must be, and how we predict risk in system design. Without this mathematical concept, we would not be able to measure security, estimate threats, or make reliable decisions when designing systems. These concepts help IT professionals create safer systems, stronger security, and better predictions, which is why they are very important in real-world computing.